Right. Right, everyone. Welcome to the second lectures of the Introduction to Big Data Ecosystem. Today, last week we talked a lot about big data, right? We talked about that big data is something that contains three main properties, right? High volumes, high velocities, and high varieties. Today, before we get into solutions that tackles those three challenges, I will need to talk about technologies first in brief that people use nowadays, so that you have a sense of which kind of technologies should we use to tackle those challenges, right? And it will also be some of like a huge recap through the database courses that you have taken before. For the third year, you have taken it like you took it like 2 years ago, right? For the second year, you took it 1 year ago. So I believe that this will be a good recap for you as well. If you want to take the slide is now available on the course website as well. So you can go to the course website and download the slide so that you can go along with me. Okay? Any question before we getting further? No, I think if you have any questions, drop in chat, right? So, recap, I already told you that the three main properties for big data that Gartner defined is high volume, high velocity, and high radius. If you look into other sources, you're gonna see 4 Vs, 5 Vs, 6 Vs, 7 Vs, whatever. They're just putting more V's on it, more properties on it. But there's no right or no wrong. It's just the matter of definitions. But for me, for this course, I will stick with these three main properties. Okay. We also talk about some solutions, a high-level solution, high-level ideas on how to tackle challenges from each properties. For example, if there is in high volumes, then perhaps it cannot be fit in a single matching. So we're trying to do data partitioning and horizontal scaling to solve it, right? But when we increase the number of machines, the system, the whole system that consists of multiple machines, seem to be likely to be more unreliable than the system that have like less or fewer machines. So to improve the reliability, or like to make sure that the system still available most of the time, we're trying to use a solutions of data replication, right? But well, since the data is now distributed across multiple machines, then we need to have a new way to write a program so that we can gather data from multiple machines. And we're gonna learn about the new way, which is called distributed programming, so distributed processing. All right. For challenges from velocity varieties, there are at least two challenges that I pose to you, right? Which is about the schema. The schema is the structures of your database. The easiest one is, let's say you have one table. The structure of the table is how many columns are there, what are those columns, what are the types of those columns. Those are schema, right? What are like the maybe primary key, foreign key, so on and so forth. The structure of the table, not the data itself, right? We saying that for big data, the data that coming into the system, some of the data may have different fields than the other, different columns than the others. So we need to have some way to adapt with those kind of data, right? And one of the ways to use technologies that rely on flexible data models, right? But again, I told you that this is just only one of the ways. So there are multiple ways to deal with it, okay? Or maybe the data coming in, we cannot predict the schema at all. Maybe they contain a lot of details, or we just cannot predict it. So perhaps we may want to store the data directly without structuring it, without organizing it. And this goes to the solution that we're trying to use files or blob storage. Okay? And the challenge from velocities is that data coming in a very high rate. They could process them more times. So I told you that the first solutions, the first possible solution is, okay, it coming to a very high rate. You cannot process it, then don't process it right at that moment. Only process the thing that is matters, and then you keep all the data that you could, you are not like, it is not that important aside somewhere else. And then once you feel like it's a time, or once you the system are not that peak anymore, then you process those like less important data. Okay, or maybe you want to have some technology that you can process some data or pre-process the data on the fly when they are coming into your system, which is the stream data processing. Right, so we have those challenges and solutions. Coming to this volume velocity and variety and velocities models. Okay, last week I also showed you some data pipeline, right? From Uber, right? Uber, they handle a lot of data, right? And they're trying to minimize the latency. Latency here means the durations from the start to the end of the process, right? For example, maybe the process of storing, well, as a user, maybe you want to see the storage, the process of we're trying to order a food, right? So when we want to order a food, then we need to pick some products, right? And then hit some submit button so that the request gets sent to the Uber. So this process should not take that much time. Well, usually when we talk about latency, we are not talking about the latencies of the human process, right? The process that human take part. We mostly talk about, okay, the time you send data, this send a request to the system, and the time it responds you back. What are like how much time do they need to spend on this period, right? And those, most of them we are trying to, we call it latency. And we talk about that there are many ways that they're trying to structuring the system so that they can handle this big data challenges, right? But if you look at this, the structure, you can see that it consists of not only a single database, right? It's unlike what we did in our database course before, that we only have one single database management system, and we're trying to plug in our applications and use it. But for the Q system, you can see that there are multiple databases, multiple database systems. You link it together, right? They are working together. Right, generation 2 and 3, and we calling this kind of like a data pipeline, because you can see that it looks like, okay, data start with this at this stage, right, and then they move to the next stage, next station, next station, next stage. It looks like a pipeline, so that's why we call it a data pipeline. My question is, okay, Uber already got the solution for the big data, right, and it is proven as well. So why don't we just copy what Uber did and then do it the same for our problems, big data problems, or big data challenges that we are facing, that we are facing? Why don't we just do it, and that happy ending, so you don't need to take this class anymore. Just learn how to build this system like Uber, and that's it, right? I just need to teach you like, okay, how to put on this key value database, put on this Kafka, put on this ingestion, put on this Hoodie, put on this Presto, Spark, ETL things, and that's it. Right? So is that all about this course? Well, there is one word called over-engineering. Over-engineering is a word used to describe a moment that you're trying to do something a lot more than it should. For example, if you want to make maybe a fried egg, normally typically people just make fried egg with a pan, right? But you say that I saw like a restaurant. They're trying to build like some furnace, a huge furnace, and I would like to do it as well. The question is that what you should do? You should spend all the money on that furnace, and then to make only a fried egg. Well, if you want to save cost, if you want to save your money, then that might not be the way that you should do, right? You should make it more cost effective. So you should just buy some pan, or maybe just order fried egg from um, existing restaurants, right? So the word over engineering happens here, right? You're trying to do some things a lot more than it should, and it deplete you a lot of money, a lot of effort, unnecessarily, right? So this course, actually this lecture, I would like to tell you that we're not gonna teach you. Um, well, we will teach you as well. That is a part of the course to setting up these technologies a little bit. But the more important thing is that how are you going to design this data pipeline for the big data for your own big data challenges, right? That fit in with your big data challenges, and it's not that over engineering. You know whether it is not over engineering if you understand the rationale behind each pieces, each bit and piece in the huge systems here. Okay? Any questions, comment, concerns before we step further? Now let me drink some water. That's good. Okay. So there is a word here that those who do not remember the past are condemned to repeat it. So there are many things that people have already invented in the past. There are many things. But what we say is, based on this quote, whether it is true or not, but mostly it is true most of the time, it is good to learn the history so that you don't repeat the history again, right? So that you don't reinvent the wheel, okay? That is why today we're going to talk about the history of data technologies. And you can see that there are a lot of bullet points that we're going to cover today. That is why I'm warning you ahead of time that it could take hours, maybe 3 hours for this lecture, so be prepared, all right? Well, we're going to start with the simplest one, early data processing. Well, back then when computers were not that popular, computers are still in the research labs. When people do data processing, also, so by the way, just a disclaimer, I generate this picture from Gemini. So just to so that they can visualize to you better. So back then when people are not familiar with computers are still in the research labs doing some rocket science things. People just use pen, right, and book, paper to note down, to write down data, right? Let's say if they want to find a sale for the companies, then they need to calculate by hand, or maybe better if they have some calculators, right? But that is what they need to do back then. Well, the problems of putting data physically is that you're going to have a lot of inefficiencies if you compare with nowadays, right? The current era. For example, humans need to do every single thing. Need to note down data, need to calculate the data, need to search for the data. All of them are the human duties. And human, we are not like, even though we can be trained to be fast, but there are still a hard limit of human, what human can do, right? If I ask you to search for like you, if I let's say you have a libraries of books, right? A libraries, and I ask you as a human to search for the book starting with the letter A without using any digital systems. I believe that even with a faster human, you will still take like hours or days to do it, right? Depends on the size of the libraries. So humans, we still hit some hard limits of what human can do. That is why I'm saying that if you're storing data physically, then it's likely that you're gonna have poor time efficiency, right? In terms of space, oh, this is very true. Imagine you're storing data, a terabyte of data on a paper, right? A terabyte of data would be tons of books, and tons of books need a place to be kept, right? But nowadays, if you want to store a terabyte of data, what do you need? Maybe a single small hard disk drive, right? A single small solid state drive. That's it. The size is just around this, very small, right? So that is why if you store data physically, then space, it's not a good usage of space. And lastly, humans, we made a lot of mistakes. You know, we're not that 100% accurate. Pretty similar to AI, by the way. So we can be precise in some sense, but sometimes we can also make errors. We cannot rely on human 100%. So this means if we still store data physically and we need human to process the data, then maybe one of thousands, there could be one of thousands that humans can make mistake on this data processing, in which for some data processing task, this is not acceptable. For example, banking system. Let's say for banking system, if they are human, maybe you're trying to store some deposit some money, right? And the human that make a record of your banking account, they put zero, one digit. That's matter a lot, right? That's matter a lot. So these are the inefficiencies. You're trying to store data physically, and and that is when computers arrive, right? Computers are trying to mitigate all of these inefficiencies. For example, computers are fast, so you're gonna have better time efficiency. Storage devices in the computers are a lot smaller, so you're gonna have better space efficiencies. And computers are very accurate. It's almost 100%, right? So computers gonna be more, but definitely computers are more accurate than human. We're not talking about AI. We are talking about like a typical computer task. If you write a program, it always gonna execute and then give you the same result, always, right? Almost 100%. Yeah. So that is why using computers, when computer arrives in data processing, it was a lot more efficient. Okay. One of the good thing is that if you want to process data, instead of you using human with a calculators and you put blah, 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 and you trying to compute some things, which could incur human errors, now you can write a program, right? Write a program to process data. Right? For example, if I have this CSV files, if I have these files on my computers, I can write this Python program so I can find all the songs starting with P, right? I mean, since you are the second year, the third year, I expect you to understand this code right now. Okay, so that's the things. You can easily write a program to process it instead of you need to use human. Even though the song list I have could contain million songs, a million songs of songs. I can still use this program to quickly search for it, right? I doubt that it's not gonna take more than minutes. It's gonna take seconds with the current performance of typical computers, right? But if you use human to search for the song started with P in a book, it's gonna take hours or days, right? The problem with this is that still you need to write a program every single time, right? If you want to do some new data processing tasks, right? It's not only time that you need to spend effort as well. Since you spend both time and effort, sometimes, oh, I feel so lazy, so I'm trying to write some buggy programs, the program and it contains bugs. Or maybe, oh, I'm too lazy, I'm gonna write some very inefficient way to process data. That could be an issue as well, right? Or if, let's say, if in this song list, instead of have only 3 columns, I have like, I changed the column name from title, from title to song name. Which means I need to fix all the program relevant to the title to titles, right? That I'm trying to use over titles. Oh, that is not efficient at all, right? So this is what it need to be. This is what is the issue. This is what the issues of writing programs every single time if we want to process data, even though it's much more efficient than the past, right? But still, we still have new issues coming through, right? And much more. Well, if you are the third year students, you may, not sure whether you still remember this or not, but this is one of the slides that I have taught you in the database course. It's not exactly the same, but the content should be the same, right? So that is why we have database management systems, or the DBMS, especially the relational database one that I hope that you all are very familiar with it, you all love it. Otherwise, but I'm not sure whether you're going to be enjoy with this class or not. So, previously, the applications that contain programs, right? Actually, application and programs are much more the same. The programs interact with the database. Database here is not database management systems, okay? Database here is just those CSV files, could be some Excel sheet, so on and so forth, could be some text files. Well, I told you earlier that database is a collections, like organized collection of data. So these databases are just like the files, and an application is going to write a program to process these files in order to gain insights that they want or gain answers that they want, right? But with a lot of problems or a lot of issues that I told you. Oh my god, oh my god, oh my god. No, give me a moment. Okay. With a lot of issues that I told you. That is why DBMS database management systems comes and step in as mediators between your application and the database itself. And these DBMS will help solve the previous problems that we talked about. If you help application easily facilitate the database, right? Basically, these DBMS are like some other powerful abstractions that are gonna help you a lot, right? There are a lot of DBMS in the world. The popular ones are SQLite, PostgreSQL, MariaDB, SQL Server, Oracle database. Oracle database is one of the first commercial relational database system. That is why Oracle right now, I think that it's one of the most research companies in the world right now. We have MySQL, and if you pass my course, right, database programming, then DuckDB should know DuckDB very well. So what DBMS help you? So instead of you need to write these large programs every single time, you only need to write this SQL or this simple queries. It's a lot better, right? Only 3 lines of code written in readable English than the cryptic Python things, right? Even like non-programmer or non-technical people could try to easily understand SQL than Python, right? And these SQL things are also a declarative language, which means you don't need to specify how to find data. You only need to specify what you actually want, or specify a query or a question to the database. So it is a lot more easier, right? And with a lot of types for DBMS, or database management system, from back in 1970s until now, relational databases or relational database management systems has been one of the most popular one until today. So the relational, just a recap, relational DBMS is a database management system that is based on the relational data model coined by Ted Card. The quick characteristics of the relational data model is that all the data are abstracted as relations or tables, right? It contains a high-level query language like relational algebra or SQL, right? So you only need to access the database. Instead of you need to write program in programming languages, you only need to use SQL, SQL, that's it. And relational database, one of the goals is that you want to reduce the data redundancies. So with less data redundancies, you're typically gonna have smaller data, and also most of the time with less data redundancies, you could have less errors as well. Because if you want to, let's say, if you want to modify one data, but for this data, you have 10 copies of it. If you modify this data, you need to modify all of these 10 copies. Otherwise, your data would not be consistent. So given this 10 copies, if you only store it as, if you don't have a lot of copies, you only have one copy of data, then when you modify this data, that's it, right? All the data changes. So given the relational DBMS, it makes data mostly stored as tables in the digital systems. I mean, in the physical system, in the physical world, people just love tables back then already. But with relational DBMS, it made many data that people store are in the forms of tables. Right? Any questions? I believe that till now, all the things I talk about, we have already covered in the database course. So for some of you, it may seem a little bit boring, but just treat it as a recap, okay? A review, right? Any questions before we move on? Oh my God, we have 41 people. Hi guys. Good. Then, okay, relational database management system come save us, right, from those inefficiencies, those problems. But back then, when the relational database management system just rise, people don't have their own computers. People just use like maybe like the company computers, which only have one of them. People just use like some mainframe, which is a old huge computer back in the days, right? But nowadays, most of the people in the world do have their own computers, whether it's in the form of a laptop, in the form of a smartphone, in the form of a tablet, smartwatch, right? Whatever. So people just own the personal computers. And with database management system, it is easy. It helps us be able to share the same database using multiple users. Oh, sorry. Given we have multiple computers, multiple personal computers, each personal computer can connect with this database management system to access the database, right? So it's helped us a lot, right? With database management system, it helps us a lot. But with multiple computers, which means people can update the database concurrently, right? People can update the database concurrently. Concurrently means that they can use the database at the same time. They can insert to the same database at the same time. They can update the database at the same time. They can right? They can manipulate the database at the same time. What's going to be the problem of this? Well, we're going to get a problems of the data race or the race conditions. What do we mean by data race? Data race is that, let's say, computer A, B, right? In the database, we're trying to access the same row. Let's say this row contains the balance of C, which is this guy, right? At first, it contained maybe $1,000. So, A would like to deposit money to C, $50 to C. C would like to withdraw money maybe $100 from the balance, from the account. So in order for A to deposit money, there will be multiple steps, right? The first step is that we need to know what is the current balance of C, right? So we need to read balance, from C, right? And then we need to add like with $50, right? And then we need to store the result from 2 into balance of C, right? For C, they want to withdraw $100. So C could be we need to get the old balance of C first, right? And then we need to subtract by hundreds, and then we store the result from 2 to the balance of C, right? If these processes are executed independently, are executed not at the same time. So for example, okay, A do this first, right, and then C. So if A do it first, then we're gonna get 1,000 here, right? Let me change the colors. Gonna get 1,000 here, right? We add 50, so we get 1,050, and then we store it from 1,000, it change to 1,050, right? And then C also want to withdraw it after A. Okay, C, now read the balance of C. So we get C, the first step, we're gonna get 1,050. Then we subtract it by 100, so we get 950, and then we store it back, so we get 950 at the end. Looks good, right? But if A and C are doing this concurrently, if they are doing this concurrently, what's going to happen? So let me change the colors to purple. So let's say, okay, A, read the balance. Good. We get $1,000. Then, okay, we do this? Okay, let's say that A do the second step. A got 1050, but before A do the third step, C start the process. So C lead the balance. C got 1000, right, for the first step. Then, okay, A, at that time, A are able to do, A is able to do this, the first step. So it update the data, it update the balance of C to 1050, right? C, now the process, the rest of the steps, right? They do C subtracted by 100, so get 900, right? And then C store the result here, 900 back to balance A, balance C. So eventually, balance C is just 900, which means the effect of this, that A trying to deposit to C, is gone. It's lost, right? So this problem is called the loss of this problem. And we don't want this to happen, right? That is why. Oh, by the way, before we get any further, do you understand all this? I mean, for the second year, we have already covered it in one of the lectures last year. I'm not sure whether you understand it or not, so that's why I try to repeat it. For the third year, I don't think I have covered it. I'm not sure whether other courses have covered this or not. But yeah, that is why I'm trying to repeat this again. So this is really important because this is one of the key things and important ideas of the database management systems back then. You understand this, right? Any questions on this? So there's a questions asking me whether what actually is concurrently. Concurrently basically means that there are two processes in the same period of time. In the same period of time, there are more than one process are running. That's it. So in this example here, mean that the process of A trying to deposit some things, and the process of C trying to withdrawing money, a certain amount of money from the account, are processed concurrently. So in the same period of time, both of the two processes are executed concurrently. Are being processed concurrently. Any questions? I guess no. So, but still, if you do have any questions, but you're afraid to ask, just put it on forum, okay? You can mark it as anonymous, so you don't need to be afraid of it, okay? Okay, I'm gonna remove. So that is why database management system back then, actually until now, they support something that is called transaction management. Transaction management is used, sorry for the bad grammar. Transaction management is used to manage multiple queries running concurrently, right? Actually, this is not quite correct. It's more like this. Multiple transaction. So transaction management is a duty of most database management system that use to manage multiple transactions running concurrently. When we talk about transaction is something like this. Okay, so the transaction basically is a set, more in the database management system, is a sequence of queries. Okay, so we can have a set of multiple queries. The transaction management in the database management system trying to ensure that multiple transactions are logically running in isolations, running like there's no other transactions at that moment. Okay, I'm not gonna go into the details. That is not the focus of the course. If you want to get into more details, there is a previous recording of transaction concurrency control lectures last year for the database course. You can also watch that video. There will also be the transaction management lecture for this year database course as well. So you can also watch that video as well. Okay. So just a review, transaction is basically a sequence of read and write operations. It's not actually a query. It doesn't need to be a query. Small read and write operations in the database management system. So with the transaction management, most of the database management system, they're trying to ensure that either all or none operations must be executed. This means that, let's say, if our transaction have three operations, three read and write operations, all the three operations must be all executed. Otherwise, none of them must be executed. Okay, that is one thing that most of the database management system guarantee. The next one, all values before and after the transaction must be correct according to the constraints, integrity constraints that you put. If you say that this is primary key, this is foreign key constraint, this column have primary key constraint, this column have foreign key constraint, this column has a check constraint, this column has like a unique constraint, those value in the columns. During the transactions, it may not be correct, but after the transaction, it must be correct. Okay. Isolation means that this is what we talk about in the last slide, that a transaction must be running as it is the only transaction, which means, let's say even though there are two transactions running at the same time, database management system must ensure that the effect of another transaction must not interfere with the other transactions that are running. Okay, basically we don't want the last update problem to occur. Right, and finally, if the transaction is committed, its effect persists, which means once the transaction is ended, there are two ways to end the transaction. The first way is the transaction is all executed, so we commit the transaction, which means all the effects must be persist. Persist here means that even though the transaction ends and we power off the machines, when we turn it back, when we turn the machine back, the effects of the transaction must still be there, even though we turn off the machine, even though the machine is broken, unless if the disk is broken, that's going to be another story. Okay. Right. An alternative. So I'm saying that there are two situations, right, that could be happening. The first one is all of the operations are executed. Another one is if the transaction is failed, meaning that maybe at some point it get into some errors, or at some point we don't want to proceed the transaction. If this happens, then the effect must not be persist. Okay, it could be persist, but durability here doesn't mean that it need to be persist or not. Okay, it just if the transaction is committed, its effects must be persistent, right? So these four properties from the transaction in most database management systems, forming one word called ACID, right? ACID. The first property is called atomic cities. The second property is called consistency. The third property is called isolation. The fourth property is called durabilities. We take the first letter, we form the word acid. A fun fact is that actually the word consistency here, you can see that it seemed to be somewhat odd from the others, because actually at first when people thought about these four properties, they only thought about three properties, A, I, D, right? And it doesn't seem to be a good name, so that's why people put the word C inside of it, right? So we got acid. Okay, this is about transaction. Any questions before we move on? If you want to make sure that your queries, a sequence of queries, have these properties in the most database management system, you need to put on begin transaction and commit before and after your queries. Okay. Otherwise, your database might not ensure that. Might not ensure these properties. Right? Any questions before we getting further? Cool. Right? Moving forward to the next one. So, you know, internet, when internet rises, before I was born, I believe it's also before all of you was born as well. People, okay, they have personal computers, but they have not much to do with it, right? Okay, they can do simple data processing, good, but people are not generating a lot of data, right? But with internet, we have a lot of applications on website, right? On mobiles, right? And those applications, they generate a lot of data, massive amount of data, which causing so-called big data, right? So that is why we're gonna see a lot of data processing, a lot more common with these applications on website, applications on mobiles, right? So for the website, we running web application on our web browsers, right? Our web browsers typically gonna talk with some server. So this creates something that we call a client server system. So instead of we let client talk with DBMS directly, the client will talk with another mediators, which is the application server first. And then it will let the application server talk with the database management system. Why? Why we don't let the client talk with the database management system straight away? Why? The first reason is that web browsers, they have limited functionalities. Some of the functionality we cannot just like directly talk with database management system in all the possible ways. They are limited in terms of capabilities. That is why we let the browsers talk with a mediator like server first, so that the server with more capacities, with more functionalities, can talk with the database management system with like in a lot more ways, right? Another one is more on the security purpose, right? So if you let all the client talk with the database management system, now everyone can manipulate database. Even though in database management system they have some security modules that they're trying to block some securities, but with a lot of people trying to approaching a database management system, that is not a good idea, right? That is why we're trying to put some this server beforehand, right, in front of the database management systems for the security purposes as well. Okay. So this is what normally people do nowadays. So let's say if it's trying to set up some web application like Migrate, I also do something like this. If someone here in the room, I believe if some of you have done web application development before, you're typically gonna do something like this, right? So this is more like a very common pattern in nowadays software engineering world. That when people try to build some web application, they do something like this. That's it. Right? With this kind of things, you see that now many applications are talking with a server, with the database, generate a lot of data, tons of data. With ton of data, businesses or organizations are now start to be interested in data analytics, right? I mean, with just a few data analytics seem to be not that appealing, but with a lot of data, now we want to rely on the data to make a more precise or more accurate decisions. So that is why we're starting to think, businesses start to think about data analytics. So normally when we build web applications, the applications start with the database management system, workloads, or the way that it talk are mostly transactional. Transactional means that you're trying to measure users, trying to generate or modify only a small chunk of data. Right? Then they're not using the entire database. They are like using just some of the database, some of the data in the databases. Right? We are call this kind of workload OLTP, online transactional processing. Okay. But now, workloads are more analytical. Especially in this AI era, many workloads are analytical. Means that a single query, it uses a huge chunk of data. And this is called OLAP, online analytical processing. If you look at this, the OLTP carefully, I'm saying that when we talk about transactional workloads, they usually involve multiple users, which means the concurrency things is really important, right? But when we talk about analytical, usually talk about, okay, we have a single query, but it works with a lot of data. So the transactions or the concurrency thing is doesn't matter that much. I say that it doesn't matter that much, but still, for some sense, it still matters. Okay. So we have two workloads, right? Back in like maybe 10 years ago or less than that, or a little bit more than that, there is another term called hybrid transactional and analytical processing, or HTAP, for the workloads that are mixed. Most of the time, when you build applications, you are building transactional applications. For some business that have a lot of data, they are only going to build an analytical systems to process the data from the OLTP system. So most of the time, these two systems are two separated systems. But there's some people saying that, oh, if we can have like a single system that can do both, then we can reduce the engineering cost. So that's why there are another type of workloads called HTAP. Right. But that's very rare nowadays. Maybe in the future that might be a new directions for the workload in terms of data. Okay. So let's see the example for each types of workloads, right? OLTP, online transactional processing. For example, let's say if Alice wants to post a questions on forum, right? You know forum, right? You should know. So with SQL, you can write like this simple. Oh, I need to remove. Okay, the annotation. Okay, right? You can just write this SQL, right? Trying to insert values into a post table, right? That's it. And what happened here is this one will update, will insert a row in a table. So a very small piece of data, right? But there could be multiple users trying to post a questions on forum at the same time. So the system must be able to handle these updates concurrently, right? Another type of OLTP query. Let's say guide me want to read the 10 most recent posts on forum. So trying to make it more fancy, but our queries, it has join, right? Inner join. Here is also do order by and limit. These are still OLTP queries, right? We are talking about a very small piece of data. Right? We are not talking about large piece of data. Okay. But still, some of you may argue that hey, we have this order by, and if we don't access all the data, how do we know whether the data are ordered in this way? Some of you may saying that most of the database management system that they prefer OLTP workload, they will have some approaches. I can tell you like they're trying to have they provide you with indexes, right, that allow you to access this top 10 without the need to access all the data. Okay. The example of these indexes are like B plus 3, something like that. Okay. So they use the three data structures to make sure that we don't need to access all the data for this kind of queries. If the database management system that you use to run this query are very poor, are not that good, maybe you need to sort all the data, which means you need to access all the data. Okay. But most of the time, this will still be the OLTP queries. But well, I would say that the lines between OLTP and OLIP for this query is a little bit blurry, right? So it just depends on what you're talking with. Okay, let's see the actual OLAP queries that it's very hard to argue. Let's say พี่หนึ่ง want to see how many questions are there for each course. If you want to write your queries, you need to do grouping, right? You need to do group aggregations. You put group by, right? You group by the course ID, right? And you do count, right? So now you know the number of posts for each course, right? Pretty easy. But in order to do this, you need to read the entire post table. Imagine that forum is not used for only for us, right? But it used worldwide, globally. There could be billions of posts. Billions of posts. Come on. Reading all of them would take a lot of time, right? So this is something that we call an OLAP queries, right? So you see difference between two workloads, right? Well, OLTP is more like we are working on only a small set of data, but OLAP query we are viewing like the data, like in more, like we are viewing the overview of the all of the data, right? We're trying to compute some statistics based on all of the data or a large piece of data, right? Any questions before we getting further? Any questions, comments, concerns? All right, anyway, before we getting further, I would like to put on a quick break here, a 10-minute break here, then so that you can go to the toilet or yeah, just take a break. Come on, 10 minutes. So we're gonna get back together at 10:20. Okay. All right. If you have any questions about assignment or regarding lectures, I believe that this is a good time for you to ask. Okay. Someone saying that have received the course email. Can you send me an email? say I forgot. I'm afraid that I'm gonna forgot your message here. Okay, the one that you just sent me a message. Okay. By the way, any questions on assignment number one? Well, I mean, for the assignment number one, I know that it's not that hard. Um, I just want to warn you in advance that if I feel like your essays are written by AI, in which it's pretty easy to sense, right? I may, I may want to meet with you in person a little bit so that I know that you understand what you wrote, okay? Or you're reading it by yourself. So please try not to use AI, okay? Try to write it by yourself. It doesn't need to be long. Essay, it doesn't need to be long, but it must be essay, you know. I mean, some of you that you submit uh, the assignment, you are not writing an essay. You just write me a bullet points. That is not an essay, right? But again, it's good that you submit things early so that I can give you a quick feedback. If you're gonna wait for like the last minute that you submit it, I'm not gonna have time to give you the feedback, right? Any questions regarding the lectures? I feel like this lecture is very technical, and I believe that you should have a lot of questions. Okay, um, there's a question from a student asking me whether they're still confused with OLTP and OLAP, right? So, OLTP are workloads that we are working only with small piece of data. Mostly, it's gonna be like, imagine you have web applications. Most of the web application, when you interact with databases, mostly you're gonna insert something, insert one row, update one row, delete one row, or maybe like showing all the data. But I mean, most of the time you're not gonna show all the data. You only show like in YouTube. In YouTube, you only show us some sets of videos, right? Those are what we call OLTP, right? OLTP mostly we're gonna see like we try to insert some small set of data, some delete some things from the database, a small set of data, maybe one row of data, updates one row of data in the database. Those are what we call OLTP. So it's a workload that we usually see in the applications nowadays. That is how they interact with the database. Right? But OLAP is that we have a lot of data. We're not gonna insert that much. We're not gonna delete. We're not gonna update. Those are very rare in OLAP. Okay, the main focus of the OLAP is to do analytics based on the data that you have. Most of the analytics, you need to read most of the data, or maybe a huge chunk of the data, in order to do aggregations, right? So those are what we call OLAP. Okay, is it clear? Or still? I would say that the major difference between these two workloads are the size of the data that you access per time, per queries. I would say that OTP, I mean, OTP workload are more like the data gathering queries, trying to insert more data, something like that. Or AP is like you already have the data, you just want to do analytics based on the data that you have. There is a follow-up question asking me if it's not a hybrid or the H-tab one, then there would normally be two systems to do each of them. Normally, yes. Normally, we have one all LTP database for working with applications, right? Facing with users. And then once you don't want to do analytics, sometimes business want to do analytics, then you will usually export the data and transfer to another analytic systems to do data analytics. Yeah, pretty similar to what you say, like use OLTP database for the updates, and then use maybe Power BI for the analytics. There is a question from another student asking me on the assignment number 1, and I think that this is a very good questions, so that all of you know. So they asked me how do I, whether like all this, how do I solve this challenge part? Okay, how should I answer it? So in the assignment number 1, there will be one bullet point that okay, you read one use case, right, and then it's gonna have like some big data challenge, and I would like you to address maybe your own solutions to solve the big data challenge. I know that it is hard because I haven't taught you most of them, but I just want you to think about the idea, just a simple ideas. Or if you cannot think about any ideas, you can also just fill in that I'm uncertain about this. I still like don't. I'm not sure about how should I solve this challenge. You can also say something like that as well, right? But these questions I added because I would like you to think about it, right? You think about it ahead of the time so that you kind of know that, oh, this is what we're gonna learn in the futures, right? But if you really cannot think about it, you can just put on you can just put that give you my knowledge right now. Um, uh, there's no solutions popping in my head or something like that. That is fine as well. Yeah, but yeah, I just want to spend some time answering that. Okay. Any questions, comment, concerns? Okay. For the assignment number 1, you need to. It's due next week, right, on Sunday. So basically the upcoming Sunday. So you need to submit it on time. We don't have any late day, right? So please do submit it, and the next week we're gonna see the next assignment. Um, as a spoilers, the next assignment will be a team assignment. It's not a team assignment. Basically, it's just a pair assignment because actually I just want you to work on together because I would like you to have two computers. That's the point of it. So that you can work on it together. Okay? That's about the next assignment. I'm still developing it. Next week I will announce it. It could be challenging for many of you because you need to write a program that you haven't written it this way before. Okay. Right. Yeah, I guess that's all for the break. Let me move on to the next one. So, most of the time, database management system. Okay, so I need to tell you this first. Well, nowadays, people trying to distinguish database management systems into two types based on the workload that I say to you earlier, OLTP database and OLAP database. There are more distinctions than this, like SQL versus no SQL, in which if you are the second year student, you know that I'm not quite like that distinction as I put it onto your final exam. Right? I don't like SQL versus non-SQL a lot. This distinction a lot because it doesn't make any sense. What I love to use is the OLTP versus OLAP. Um, so the database management system (DBMS) that tends to love tends to be good at the transactional workloads or the OLTP workloads. We call them the OLTP databases. Those OLTP databases are often poor at doing analytical queries. So they are designed for users to frequently manipulate databases. Frequently, right? I use the word frequently update the database, frequently insert the database, frequently delete the database, small amount of data, right? So given these kind of things, the storage formats that is suitable for this work gonna be something that we call row store or the NSM, right? The second years should know this already, but for the third year, I haven't covered it in your lectures, so there will be a slide that I'm gonna cover about this as well. And there will be some indexes, for example, B plus 3 that I told you earlier, right? That used for the transactional workloads or the OLTP workloads, right? So don't need to be worried if you still don't understand what the hell is row store or NSM on this slide, because there will be an example in the upcoming slides. For the analytical database or the OLTAP databases, well, I told you since the OLTP databases are success analytics, so they are another kind of system, database management system that they try to build it purposely for doing OLAP workloads, right? So typically, we do have a lot of OLTP DBMS, right? We will try to extract data from the OLTP, data of interest, the data that we would like to do analytics from the OLTP database, right? Then we transform the data, doing data cleansing, doing data pre-processing here, and then we load it into OLAP database management system, and we use the data into OLAP database management system to perform, and then we use it and then perform analytical queries on this, because analytical databases or analytical DBMS are much faster for performing those analytical queries. They are built specifically for those analytical workloads. So you can see we have the word ETL here, right? Extract, transform, load, which appear on the previous slide, previous lecture as well. ETL is basically you extract data from the OLTP database management system, we transform it. So there are two technologies here that we're not going to cover in this course, but you should learn it. You should learn it by yourself. The first, both of them, they allow you to form a program to extract data and then transform the data into an appropriate format, then load it onto your database management system that you want, the database management system that you want, right? I think I will cover a little bit of it in the fourth lectures, but not gonna be a lot of them. You may want to check it by yourself and learn how to use it by yourself. It's not that hard, but it is not that easy as well. But yeah, but I don't think it's that hard. So, well, okay, once you load into our OLAP DBMS, then yeah, it's good. Now you can run the analytical query so fast, right? Well, when you load it, you see that when you extract, transform, and load, you try to transform data from one things to another things, right? Which means you may want to have different schema or different structure of the database, right? So for OLAP, a very popular schema is the stars or the snowflake schemas. This one is a snowflake schema, right? The snowflake schema is like you have the central table here. Mostly we usually call it a fact table. And then in this fact table, you have multiple dimensions, right, on each side. If you're familiar with the business intelligence system, BI systems, sometimes when you import data into it, right, they will ask you to pick dimensions of interest. And those are the dimensions here. That's the same thing. I will have an example for the one that you're not familiar with this, okay? Well, so this is a snowflake schema because for each dimension, there are like a lot more super dimensions following by it, okay? But this is a star schema. So star schema, basically you have one dimension. You have only one level of, for each dimension you only have one level. For example, you have the center fact table, right? And then you have the product dimensions, customer dimensions, time dimension, promotion dimensions. So basically, if you implement this on the DBMS, you're gonna have 5 tables, right? And the fact table, the middle fact table here are tons of foreign keys that you refer to the data for from each table. The good thing for the star schema is that, let's say if you want to run analytical queries by a certain dimensions, for example, you want to know maybe the unit sold here, right? For each product per time, per year. So now we only need to involve 3 tables, right? The fact table will always be the one. We need to use it, right? And then we need to incorporate with the dimension, the product dimensions, in the time dimension. So when we write a queries, then first from fact table, this is the definite one. Then we only need to join the products and the time table or the dimension of interest, right? We join products and times. And then we can do just group by and then select and do sum. That's it. You can write the analytical query will be very easy if you are doing star schema and you know the dimension of interest. So this is when people try to have another analytical systems here, the OLAP system here, right? They will try to design their own style snowflake schema, usually do it, so that when they perform data analytics, it is much faster, right? Okay, any questions, comment, concerns? Okay, I believe no. So with the star schemas or the snowflake schemas, they are new operations that people just invented, but basically you can perform it with SQL. We call those operations the data cube operations because now we have your data is not only a single dimension. we have multiple dimensions, right? So with multiple dimensions, the people invent like new operations called roll up, slicing, pivot, dicing, drill down, something like that. So roll up means that you're trying to group your data by a single dimension, right? Something like that. Dicing means that you're trying to group data into some small pieces, something like that. You're only trying to select some small piece of the data based on the group or based on some dimensions, certain dimensions. So I'm not going to cover this in detail. You can check it out on this website. I just want to say that if you use OLAP database, or the database management system, that tends to prefer the OLAP analytical queries, then you could see these roll up, these data cube operations as well, inside of it as well, and you can play with it. And one of it, right now, the currently very popular one, OLAP database, is called ClickHouse, right? Many companies in Thailand, they are trying to research it and then trying to adapt it onto the company. Okay, there is a question saying that, asking me that fact table contains all the foreign key that will be used in the analytics. Yes. And also some values as well. Right. Some values for the facts as well. Right. Fact table is like the smallest piece of data in the schema, right? With saying that, oh, this product at this time for this promotions and this customer, this is a revenue that they got, this is a unit sold that they got, something like that. And if you want to see for each product, then you need to group by with the product, group by the product ID. You want to see for each time, then you may want to join with the time and then group by either month, quarters, something like that. If you want to see for each customer, then you can just group by customer ID. If you want to see for each ad types what is the revenue, then you can join with the promotion table and then group by ad type, something like that. So that is why in the fact table, all of this, you need to have the foreign key linked with the dimensions that you are interested in. Okay? All right, let's move on. So, well, I think that maybe this lecture could be only 2 hours long, but we'll see. So, the reason why the OLAP DBMS are faster are at least the following reasons. Use the columnar storage. It have better data compressions. It have vectorized processing. It has some specialized analytical indexes, for example, zone map, count, min, max, sketch. I'm not going to cover it today. If you want to know it, you can ask me. Okay, feel free to ask me. Right, zone map. I have talked about zone map in a little bit in the database class last year. It's not in the lecture. It's only in the quiz and the exam. Right? Okay. So, analytical databases, they're using columnar storage formats. Right? For example, if we have this table, let's see, the typical format that people use in OLTP database is called NSM format or the row store. Okay, so let's say if you're trying to run OLAP queries on row store, which is, I can give you a heads on that it is not that good. How would it be? So I have this table. I would like to run these queries. These queries, basically, we're trying to count the number of posts for each course. Okay, so basically we only need to use one table, right? We only need to use this table. Okay. When the database management system trying to run these queries with the NSM format. So first, this is the way that they're gonna store the table. So pretty straightforward, right? So they store post ID, type, content, course ID, and the date time here. And then for each row, they store them contiguously, right? Then the next one, after the first row, then they store the second row, the third row, the fourth row, and the fifth row, right? If we want to do the OLAP queries here, what DBMS need to do is first, okay, it starts with at the beginning of the files, then it need to run to see the course ID, right? Because course ID is what we are interested in. Then we keep the counter on, so we have this table to keep the counter for each course ID, right? And this table for the second year, this is basically the hash table that you have implemented before. Okay. So once we run into this point, okay, we found one. So basically, we just increment the course ID one by one, right? And then we see the end of the row, and then we need to move on to the next row. Oh my God. Okay, and then we need to again run to see the course ID columns. Okay, then we increment the count into 2. Again, we do it again. We run it to the end, and then we move on to the next row, and then we run to the course ID columns, and then, okay, we add new entries, course ID 2, the count 1. We need to run through this, like, we need to run like this until we reach the end of the file. So basically, we need to read all the entire data. That is the cost come with the NSM format. Okay. You see that you only want to run this, right? You only want this column, right? You only want data in this column. You don't want to read this thing. You see how unnecessarily expensive it is. So that is why I'm saying that if you use OLTP database, this is what you need to go through. And I don't think you would want to do it. Okay? How about for the DSM format or the column format? Basically, for the column format, you store value in the same columns contiguously. So instead of the NSM format, then you store value in the same row contiguously. Now you store the value in the same column contiguously like this. So this is the course ID column. Okay, but we also store the post ID as well, because we at least need to have some primary IDs to refer to it. Okay, so we have this one is a post ID 1, post ID 1, course ID 1, course ID 2, course ID 1, course ID 3, course ID 2, course ID 4, course ID 2, course ID 5, course ID 1. Okay, yeah, that's good. Okay, so this is the content. So we store each values in the column in the separated files, separated places. Okay, which means if you want to run these queries, we only need to run through this small chunks of data. Looks good, right? We only need to run through this. That's it. You can see how much less data we need to access if you store it wisely, right? So this is why the OLAP queries, they are they love the data storing in the DSM format or the column format. Well, most of the OLAP database management system, they are not storing in the DSM format, sadly, but they are storing in the hybrid format, right? Or what they call packs. Packs is the partition attribute across. Basically, they group rows together, right? And they pack value in the same column. So for each group of rows, they pack value in the same column together. So basically, so let's say we have millions of rows, right? Maybe they may be chunked like a group of hundreds rows together, and for that group, they store the column values together. Right? Let me draw some pictures. So let's say we have one M rows, right? We chunk it into a small chunk, maybe small chunk of 100 rows. And then for each group of 100 rows here, so let's say we have column A, B, and C, right? We store column A data in the column A together. Then data in the column B is together, and data in the column C together. We group them together, we call this a row group. Right? Then we're gonna have multiple row groups, right? Storing in the same way. So this is a PAX format, the hybrid format. There is a questions from the students asking me whether about the DSM. So we need to take. I'm gonna take a pause here, and then I'm gonna go back to the DSM. Okay. So they asked me whether what is 11221. Okay. So the first one is the primary key, right? And we have course ID. Because even though if you only store the course ID, the problem is that how you're gonna know that which course ID this one is, right? You need to have the way so that you know that, oh, this is the course ID for this row. So at least you need to attach the primary key with it. Okay, so these numbers are the primary key. Okay. Very good. I think that is a good question. That's why, actually, that is why they call it a decomposition. Because they're trying to decompose a huge table into small tables. Okay. Okay. Well, get back to the PAX one. The PAX one. Well, basically, we group rows together. So we group rows together, and I need to say that for each group, we pack the values in the same column together. So basically, we chunk up rows, or we chunk up the entire table into multiple row groups, and for each group, we do the DSM. That's it. So it means that for each group, we can fastly go through each column values easily, right? But okay, we may need to do some jump here, right, in order to access the next row group. So it will be a little bit slower than DSM, but not that much. It's only a little bit slower. Okay, so that is why many OLAP database they prefer the PAX. They kind of like they prefer PAX formats rather than DSM. Another reason is that queries mostly they're not going to access only one column, even though it is analytical. They could access like 2 or 3 columns at the same time. So it is better not to like make the values in other columns far away. That is why if they do it as a row group, then they can still access the data in the other columns as well for the same row. Okay, so PAX basically have a table, you chunk it into multiple row groups. For each group, you store it as DSM. That's it. Existing PAX format that you should know, because it is very hot right now. Parquet, Apache Parquet. Let me zoom in so that you can see the structure of it. You see the term that I use, right? Row group. See it, right? This is a row group, and in the row group, you see column A store right here. Column B store right here. Right? See that? Okay. There are some metadata here. So this is a metadata that they use so that they know the location of each they kind of like they know um, the properties or the types of the values that you are storing. So this is metadata of columns of a columns. Okay. So you see, that's exactly the same thing as I say to you, right? Another one that is very popular, I don't think it's popular in Thailand right now, but maybe soon. Uh, oh no, Apache Ox. Okay, Apache Ox I don't think it's that popular. I haven't heard it that much, but still, they're using in Spark, right? I think people in Spark love it. I'm not sure, right? But Parquet they're using very multiple places. So that's just pretty same things, right? So they chunk up row to stripe, and then for each row they group each column values together. You can see here, right? Okay. Um, yeah. So with columnars, then OLAP queries can be a lot faster. And these are the OLAP DBMS that people are using nowadays, right? The most beloved one, your most beloved one, DuckDB is one of the OLAP DBMS as well. Okay, that is why I'm trying to teach you DuckDB, because I know that many of you want to do some data analytics, right? And DuckDB is one of the very fast OLAP query or OLAP DBMS nowadays, and it's one of the very easy to use one as well. So that's why I'm trying to teach you in the introductory database course. Okay, there are other things as well. The ClickHouse that I showed you that contains some data cube operations. Some big companies here like Google BigQueries, Amazon Redshift, SAP HANA. A new one, a very recent one, not that recent. Delta Lake here. The word lake here, if you're familiar with it, I think I have said the word data lake before. Delta Lake here, they are loving to um, work with. Sorry, if you use data lake, means that you try to build some data lake thing in which it's basically a staging area for data. Okay, in which we're gonna cover it in lecture 6. TiDB, Polar is basically, if you know pandas, Polar is basically the faster pandas. That's it, right? I'm trying to teach the first year Polar in this semester. We have to reason OLAP database. CRDB. This is actually not OLAP. They're trying to sell themselves as HTAP. Okay. Another one is Spiral. This is very new. Very new. I think it just announced like last month. So it's very new. Okay, Spiral. It comes with like a very innovative way to store data. So I show you all this logo because if you want to work with OLAP queries, OLAP workload, you may want to look into them, because I know that in the future you may have an opportunity to work with one of them. Okay. Any questions, comment, concerns? Okay, I guess no. Right. Okay. I want to go through some benefits for the columnar format as well, because it will be So you have a clearer pictures of the secret sauce why it made the OLAP database can be a lot faster. Okay, the data access one, that is one thing, but there are a lot more things that it helps columnar to be a lot faster. For example, the compression. So so this is like, okay, we extract one columns from the table. Let's say it is a prices columns. Okay, so the first column here is we have in this column we still need to have primary key, right? But if the primary key, they are just arranging from 1, 2, 3, 4, 5 until 10, and then it's going uh, sequentially increase. I mean, it increase like monotonically in the same amount. We can just remove it. It is possible that we try to remove it, and we use offset instead, right? So basically, we just need to remove it, and we just assume that, okay, the first one will be 1, the second one will be 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So this is one other thing that we can do. So we can reduce the indexes, but this doesn't seem to be compression, right? The actual thing is this: if you see a lot of consecutive same numbers, for example zeros, in which I believe that some of the table, large table, this could happen, right? Contain a lot of zeros. You can further do something that we call compressions, data compressions. One of the way to do data compression is called run length encoding. So to give you an idea for the run length encoding, or RLE, is that instead of you store 7 zeros, you can store just only, okay, we have 0, but we have 7 occurrence of it, consecutive occurrence of it. That's it. Now you only need to store this amount of data. There's a lot smaller, right? So it also improves space efficiency as well. If data has common patterns, right? And with compressions, let's say if you want to do some other price, okay, you run through all of this, right? Normally you do 9 additions, right? But with compressions, let's say you store it like this, you only need to do 3 additions and 1 multiplications. That a lot cheaper than you do 9 additions. Well, I cannot say that is a lot cheaper because it's just like a very small amount of difference, small amounts of changes. But imagine for the large data that contain thousands of zeros, this will affect a lot. This will save a lot of time. Okay. Another thing is that, okay, let's say we cannot do that compressions anymore. The data are so scattered, are so random. Another thing that you can do is to do vectorized processing, in which not all DBMS do it. Okay, this is a very, I cannot say it is innovative thing because it has been here for 20 years already, but still, not all DBMS have it because it is hard to implement. So let's say you need to do these 9 additions. Your CPU, the modern computers, modern CPU, they have a special instructions to, instead of you add 3 additions, instead of you use 3 instructions to add 4 numbers together, now you can use special instruction called vector instructions or SIMD instructions. Oh, I'm sorry, I forgot to remove the annotations. SIMD instructions to just do this 3 addition within 1 instruction. It is typically going to be faster than normal, but you need to, the DBMS writers, the DBMS implementers need to be aware of this and use it. And it is not easy. Typical computer science students don't know, are not aware of this. Okay. So not many people can do it, right? But that is why some DBMS, some OLAP DBMS are much faster than the others, because they know about this, they are aware of this, and they use it. Okay. So this is gonna reduce the times by quite a lot. And for example of database that they use vectorized processing are DuckDB, ClickHouse, and Polar. Polar is not quite DBMS, but it can do vectorized processing, so it's good. So if you want to get into the data organization, because I'm not going to talk about it anymore, I will have a lectures on this Wednesday morning for the first year, and I'm going to talk about NSM, DSM, and PACS more. It will be more in detail, so you may want to check it out. I will try to publish it on Wednesday afternoon. Okay, this video, right? That's for the storage format. Oh my gosh, that's a lot, right? But I hope you gain something. I hope you know that there are two workloads and there are two kind of systems that are good with different workloads. You need to choose it appropriately, right? There are a lot of technologies. You need to find a way to, okay, I want to build an applications that have a lot of transactions. Then I need to pick some OLTP database. But let's say if you have a lot of analytical queries, then you may need to choose one from the OLAP databases. Okay. Any questions, comment, concern before we moving on? There's a question, a good question. Does a vector reduce just grouping thing in 4? Not always. So, the current instructions, I believe that it can group 512 bits at a time. 512 bits is basically 512 divided by 8, which is what? 8, 64 bytes. And typical integers are 4 bytes, so they can group 16 integers at the same time. In the current computers, right? In the future, maybe it can be much more. The size, it's one of the innovations in the hardware things. So there is some hardware limitations right now that they can do like at most 16, but in the future they can do much more. Actually, this is, I think this is something that you may want to know. Do you know why many AI, they love using GPU? When we talk about AI training, they always talk about GPU, right? One of the reasons is that GPU, they contains a lot of vectors instruction like this. GPU is the massive vectorized processors. They do tons of vector instructions. They do a lot of vector instructions. That is why they are much more faster. And I believe that in GPU, we can group more than 16 integers. We can group like thousands of integers at a time. That's why GPU are built so that it can compute this kind of thing very fast. And AI, some workloads in AI training, they just match with this GPU compute patterns. Right. Also, again, the answer is that not always. It depends on your computers. Most of the computers currently support, I think, 8 to 16 integers at a time. Some computers support like 2 integers, 4 integers. Someone open up microphone? You want? Okay, I believe that it's just by accident. Okay. Good. The OLTP versus OLAP is just like 20 or 30 years ago things. But people are just aware of, like, in this era that we have big data, people tend to love OLAP database more than before because we have a lot of data and we need some system to quickly process those data, right? Do some analytics like quicker. That is why currently in the current era, there are many new OLAP database management systems. But nowadays people just keep data on cloud, right? Most of the data are on cloud. most of the systems that you use are on cloud. Big grade that I develop are on cloud. Forum, I'm not sure. I need to ask Poom. What else? Yeah, but most of the services that you use are on cloud. So that's why many cloud services they also offer you database services as well. So and on cloud they are also OLTP and OAP one. I mean, for example, the first one is the GCP, Google Cloud Providers. If I remember correctly, but it's a cloud from Google. I think they have cloud database, the cloud SQL one, which is the OLTP database service, right? Amazon, they have Amazon Aurora, right? Aurora, right? Which is the AWS, Amazon Web Service. This one, Amazon Aurora. This one is the Microsoft, Azure, ACURE, Azure. I don't remember its name, but I believe it's Azure SQL. Okay, but yeah, Google they also have the OLAP database as well. The BigQuery is one that I talk about, right? Amazon they also have the Redshift one. And in the current era, there are two companies fighting for this OLAP cloud service. One of them called Snowflakes. Snowflakes, I think 5 or 6 years ago they just got into IPO, right? But honestly, Databricks are much more successful, right? In my opinion, okay. Databricks here, they're also trying to do OLAP services as well. But if you take a look into the websites nowadays, we're gonna talk about AI, and that's undeniable because nowadays people just talk about AI, okay? But these are two new competitors in the OLAP database service on cloud. They call themselves the cloud data warehouses. Cloud data warehouses. When we talk about data warehouse, I forgot to tell you about this. I need to tell you first that this thing, the OLAP database here thing that we trying to do ETL, we call the OLAP here that we use star schema, snowflake schema, data warehouse. Okay, they are called data warehouse. So I'll let you know new terms here. Data warehouse. I will talk about data warehouse more in the 6 lectures. Okay. Okay. Let's get back. Okay. But since most of the data are on cloud, that is why Snowflakes and Databricks are trying to invent some cloud data warehouses. And they make use of resources on cloud because GCP, Amazon, Microsoft Azure, they allow for flexibilities on the computing powers, right? So let's say if today I want to use 5 machines, I can just instantiate 5 machines and I can just use it, right? But if today, there are more users, then can I instantiate like 10 machines? You can just click on it and that's it, boom. You don't need to buy new machines, right? It is a lot easier. So Databricks and Snowflakes, they're kind of like trying to use it. Okay, so there's questions saying that so OLAP is data warehouse. I don't want to say this because it's not always. Data warehouse is more on how you structuring the data. Okay, I would say that if you store data in the sense of Snowflake schemas or star schemas, you could say data warehouse. If you store data for the sake of analytics, you could call it a data warehouse. There's much more thinking about data warehouse than that, but most of the time when we do ETL and they put data onto OLAP system, we're trying to build data warehouse. Okay. For the sake of the data warehouse, I would try to talk about it in lecture 6 for more details, but there will be like some characteristics of what is a good data warehouse, and one of them is we need to have time dimension, right? In which if you use DuckDB, not always that you need to have time dimensions, right? Which means Doesn't need to be all the OLAP DBMS doesn't need to be data warehouse. That is what I'm trying to say. Data warehouse is more like just the way you're trying to structure the database, organize the database logically. And then most of the time, you want to put the database that you're structuring as data warehouse onto OLAP DBMS because they are faster, they are much faster. But you could, I mean, it's definition thing, so it's kind of hard to say. Someone just sell the product by saying that, oh, my system are data warehouse, but really it's just like the OLAP database, you know. Okay, let me get back to this.
เมื่อกี้เสียงอะไรแอร์พอร์ต
Someone saying something. Oh my God. Okay, never mind. Nothing's happened. Okay, so the good thing for the cloud is that for the Snowflake and the database is that, okay, today there are hundreds of users. I just only need to use this much amount of compute instances. So we just need to ask for this amount of machines from cloud. Those GCP, or Amazon Web Service, Microsoft Azure, right? They're so easy, right? And the good thing is that people tend to store data on those clouds as well. So Snowflake and Database are trying to make use of it by, okay, you have data on those GCP, Amazon Web Service, Microsoft, Azure. Okay, you don't need to bring data to us. I will go and get the data, those data for you. And I will do transformation. I will help you do ETL and process the data for you. That is what like Snowflake and Databricks are trying to do. Okay, we will have one lab on Databricks so that you see how it works. Okay. The reason why we have the lab on Databricks is because Databricks allow they have some free trials, so we use Databricks. Right. The last part, AI and machine learning. Well, I cannot say it is only AI and machine learning, but well, there are much more specialized workloads nowadays. AI is one of them because it is not a typical. It's okay. It's more OLAP, but it is more specialized. It is like a subset of OLAP that we're trying to take a lot of data on it, right? From it, right? Machine learning as well, right? We need to take a lot of data to train it, some specific column to train it. So there are many specialized DBMS trying to competing in this era. Two major DBMS, actually, the first one that are more popular. The first one is more popular, the vector DBMS, vector database that people are saying nowadays. So vector database, they're basically trying to store data as embeddings. If you're not familiar with embeddings, it's basically vectors of numbers. Okay. So when we store data as embeddings, the good thing is that there is the way that we can compare two embeddings together to see whether they are similar or not, right? So vector database, one of the good things for the vector database is that it is very good for doing similarity search, which is in contrast to the OLAP and the OLTP system that we talked about before, right? Because when we talk about database, most of the time, we're trying to do exact queries or the queries that we want to gain data that is exactly correct given the queries. But for this time, we are more interested in similarity search. And the use case for the similarity search is what? AI, the LLM, like your chat GPT things, Gemini. Because we don't want we don't need the exact solution. We don't need the exact answer. We just need only like some answer that kind of like similar to the users kind of want, right? So that is why vector database are very hot nowadays in terms of AI, especially the LLM eras. Another one is a graph database management system. They are specialized on graph analytics and traversals. If you are familiar with graphs, you're gonna know that you can do traversals, right? Graph traversals. Traversals, basically, it is one traversal in graph database management system. It's basically a join in relational database, right? But they are very good to join like a lot of multiple tables together. Um, Also, they are good in terms of graph analytics, shortest path, finding shortest path, um, finding doing page rank, or finding like what is the hotspot in the graph, like which nodes in the graph are the hottest one, something like that. They are very good at doing that, and really they're used for improving the LLM accuracies. So if you heard about graph rack or the graph retrieval augmented generations, um, you can use graph DBMS as a context, right, as a knowledge base for your LLM. So when LLM trying to gather the data, right, they may find some answers. They will try to use give it the answer that they want to provide to us. They would make sure that the answer that they're trying to gain more context from the graph database, right, to ensure that the answers are enriched with the context. Okay. So let's see some example. For the vector database, DBMS, so let's say you want to store these 4 books, right? But the book is so large and it's very hard if you want to find, if you want to do some, if you want to search for a book, right? So in vector database, you usually use transformers. Transformer is basically one of the AI neural network architectures, right? Used to transform a data into another format, right? So you pass one book and you embed it into, go through transformer in order to produce an embedding. The embedding here is basically this, right? A vector of numbers. Okay. Now you do it for all the data that you provided in. Then these will create a vector space for each dot here. Each dot here represents each data, right? The red book here represents as a red dot here, right? And then let's say I have a query that, hey, can you find a book with blockchain, the book that related with blockchain? I think this is not that precise. Let me go with related, relevant to blockchain. That's more better. That's better. Can you find books relevant to the keyword blockchain? Okay. Now what you do is you take the keyword, you pass it through the transformer, you get the embeddings, then you see how similar the keywords are. Yes. Right? You see the nearest neighbors one, the nearest point in the vector space. And you say that, oh, the green one is the nearest one. So basically, this should be the output, right? So this is pretty similar to how Google's work, right? The search engine works. So if you want to develop your own search engine for your companies, for your business, vector database could be one of the interesting solutions, right? Imagine for the LLM, right? LLM, you want to add some context. You put on context into transformer and embed it into embeddings like this, right? And then when users provide a prompt, trying to put a prompt into transformer and then see whether which context, which information, piece of information are relevant to the prompt. This is how those LLM trying to find more context, right, based on your prompt. Okay. These are the example like Python, Milvus, VWeight, Chroma DB, those kind of things are the vector database. It's good for similarity search, but for the exact search, just use other databases. Okay. The next one, the graph database management system. Right, I don't have much details on it. Well, I actually do know a lot of it because that's my thesis, but I'm gonna go through it quickly. Basically, you know graph, right? Graph theory. Graph database management system, we represent a graph, we represent data as a graph, and the relationships. Basic graph is a node and edge, right? So nodes refer to an entities, an edge refer to a relationship between entities, and then we can do query to see, okay, I want to see whether this person, like how many friends, uh, how many friends are there for this person, right? So I just need to see whether, okay, from this node, who are connected with these guys, right? And you can also do page rank. Page rank is a Google algorithm to find the hottest node in the graph, right? You can also run that one as well to see. Right? So these are the popular graph database management system. Neo4j, the most popular one. Tiger Graph, the fastest one on the benchmark. For DB, they're trying to sell the AI solution based on by using graph RAG thing that I told you. Okay? And yeah, that's it. Oh my god. Okay, so just to summarize everything, relational database nowadays they're used to support OLTP applications right now. But once analytical queries are needed, you ETL from OLTP to OL. Oh, my mistake, my bad. Should be OLAP. Okay, you ETL into OLAP database. OLAP database doesn't need to be. Most of them are relational. Okay, and I believe that this is not quite that precise. So I mean, people use like relational, use document, use those kind of DBMS to store to support OLTP applications, right? But just need to ETL those OLTP databases into OLAP DBMS in order to perform analytical queries, right? And finally, we have new specialized workload, specialized DBMS for the specialized workloads to deal with AI, machine learning, or like the new workloads in the futures. Okay. Um, so just to preview the next lecture, because the next lecture we are gonna tackle the first challenge, right? The challenge about big data. The challenge about big data. High volumes of data. So if you remember these pictures, users here are not just 3 users. They are much more than 3, right? Some applications have millions of users. Some have 10 millions. How do they support? Some of them have billions, right? So at that point, you're gonna just use a single server or single DBMS to handle them. So the server gonna die, the DBMS gonna die. How to solve this? And that will be the next lecture. We're gonna talk about the database that is not only on a single machine, or basically what we call distributed databases. We're gonna talk about vertical and horizontal scalings, which is one of the solutions that we talk about, right? We're gonna talk about sharding. Sharding here is basically a database partitioning, right? And replications. So we will talk about the first 2 solutions of our big data challenge and see how it works. Okay? Any questions, comment, concern? If not, then let me stop recording.